Today we'll be looking at horizontal stretches and compressions. So to begin looking at horizontal stretches and compressions, this is when we're graphing our y equals f at k at x, where k indicates the factor of the function that is horizontally stretched or compressed. So an example of this would be y equals f at 2x. So you'll notice that the value is inside the brackets with the function itself. So if the value of k is greater than 1, the function is compressed horizontally. Notice that it is now compressed horizontally when the factor is greater than 1, whereas when we were talking about vertical stretches and compressions, it would have been vertically stretched, not compressed. And if the value is between 0 and 1, therefore a fraction, the function is stretched horizontally. So looking at an example here, y equals f a third of x. This function here is horizontally stretched by 3. Where this one here that we looked at before is horizontally compressed by a half. So now let's go ahead and look at a couple of examples of sketching them. So in our first example here, we want to sketch the following functions on the grid below. First, we're going to graph our base function y equals x squared. Again, start at your point 0, 0, 1, 1, and 2, 4. Similarly, the same points on our left-hand side of our origin. We can connect those points. And that is our y equals x squared. Now we're going to go ahead and graph our next function. Our next function here is y equals 2x all squared. So we notice that 2 is inside the brackets with our x, and therefore this would be horizontally compressed by a half. So instead of the y values of each of the coordinates being affected like we did during our vertical stretches and compressions, now it is our x coordinate of each point. So we start at our origin here. Our origin is 0, 0. It is going to stay as 0, 0. Now our point here is 1, 1. Now the x value is 1. You're going to multiply that by a half. So now our point is going to be a half 1. And up here where our point is 2, 4, you're going to multiply our x value, so 2 by a half, so it's now going to be 1. Similarly, on the other side, the points are going to be the same. And what we have here is our function y equals 2x all squared. So again, that one is a horizontal compression by a half. Now looking at our y equals a third x all squared, notice the third is inside the brackets. Therefore, I know this is going to be a horizontal. Is it a stretch or compression? So since it is a third, therefore it's going to be a horizontal stretch because our value of k is between 0 and 1. So it's a horizontal stretch by 3. So now each of our coordinates from our base function are going to be stretched by 3. But again, remember when we're working with horizontal stretches and compression, it's the x value that is affected. So our point is going to exist at 0, 0, so at our origin. Now our point that's at 1, 1 that x value of 1 is going to be multiplied by 3, and therefore it's going to stretch to 3, 1. And our point up here at 2, 4, that 2 is going to be multiplied by 3, and it's going to be stretched to 6, 4. Similarly on the opposite side as well. So you know we have a stretch factor, a horizontal stretch factor in this case, by 3. So this is y equals a third x all squared. So now what we can do is we can look at our next function here. So we have here is y equals 1 over x. So this is our rational function. Remember, when we have our rational function here, we have our asymptotes, which are x equals 0 and y equals 0. So in this case, it's just our x-axis and y-axis. So our key points are going to be 1, 1, and -1, -1. Remember, it's going to get very, very close, but it's never going to actually touch or cross our asymptotes. And in this case, also our axes. So that one there is y equals 1 over x, so our base function. So now what we're going to do is we're going to look at y equals 1 over 3x. So 1 over 3x is going to be a horizontal compression. So we have a horizontal compression here by a third. So remember, it's always the value that exists with the x. So that's why it's a horizontal compression, because our value of k is 3. So we have a horizontal compression of a third. So now what we're going to do, we're going to take our x values of our 2 key points and we're going to multiply them by a third. So we have our horizontal compression here, so 1 times a third, and below as well. So we'll have a horizontal compression that is going to exist. So this is y equals 1 over 3x. And lastly, we're going to look at y equals 1 over a half x. Now what does that half do? Remember, you're looking at the k value, and the k value is always what's in front of your x. So it's a half, and since it's a half, we know that we have a horizontal stretch by 2. So now you're going to take your base function and you're going to multiply the x value of our key points by 2. So now instead of being at the point 1, 1, it's going to be at 2, 1. And -2, -1. And we will have our points here, getting really close, but never actually touching our asymptotes. So that's y equals 1 over a half x. So now let's put that all together from yesterday's lesson and today's lesson. So our combinations of vertical and horizontal stretch and compressions. So what we're going to do is we're going to look at our function x squared, which is a quadratic function. We want to sketch the original graph as well as y equals 2f for at x and y equals a half f at a third x. So we're going to go ahead and graph those. So what we're going to do, we're going to graph our y equals, or f at x equals x squared on both graphs to begin. So we have 0, 0, 1, 1, and 2, 4, and negative 1, 1, and negative 2, 4. So that's our y equals x squared. I'm going to draw that on each of our graphs to begin. That's y equals x squared. So now what we're going to do is we're going to look at the fact that we have y equals 2 times our f at 4x. So what is that 2 going to do? That 2 is going to be a vertical stretch by 2. And remember, when we're talking about vertical stretch and compressions, that's going to affect our y value. And then the 4 here is going to be a horizontal compression by a quarter. And that will affect our x value of each of our coordinates. So 0, 0, is it going to be affected at all when we're talking about stretch and compressions? No. That point is going to exist and our vertex is going to stay as is at 0, 0. Now our point here at 1, 1. So our x value is going to be now multiplied by a quarter, and therefore is going to be a quarter. And the y value, that is 1, is going to be multiplied by 2. So our new point is a quarter 2. And then we would have negative a quarter 2. And above here, we would multiply our 2 by a quarter, and therefore that would give us a half. And we would multiply the 4 by 2, so we would be at 8. So somewhere up here, the graph's not quite big enough. So our function is going to be super, super skinny and long. So that's going to be our y equals 2f at 4x. So remember, vertical stretches and compressions affect your y value, and horizontal stretches and compressions affect your x value. So now let's look at number 2. What is this half going to do? This half is going to be a vertical compression by a half. And this third here is going to be a horizontal stretch by 3. So we're going to look, vertex, nothing is going to happen to our vertex because the coordinate points there are 0, 0. Now let's look at our point 1, 1. So if we're talking about first our x value of 1, it needs to be stretched by 3 because it's a horizontal stretch. So now that point is going to be at 3, 1. Well, we still need to deal with our vertical compression of a half. So multiply that 1 by a half, so we get this point should be at 3 1/2. Now let's look at our point 2, 4. We're going to multiply that 2 by 3, so we are going to have it at 6. So we have 6, 4. Multiply the 4 by a half since we have our vertical compression. So it's going to be at 6, 2. And those points, it's like a mirror across our y-axes, are going to exist on the left-hand side. So negative 3 1/2 and negative 6, 2. So this one here, as you notice, is going to be very fat, stretched very long horizontally here, and this is our y equals 1/2 f 1/3 x.